So this video I'm going to run through the questions for quiz 15, which is revision on CC3 and 4, which is atomic structure and periodic table, and then a few questions on the topic we're doing at the moment, the atmosphere. So the first question they asks you about atomic number. Alright, so there are two numbers next to every element in the periodic table. The atomic number is the smaller number, and the smaller number tells you the number of protons. Now I know you can also get the number of electrons from that small number, but it's called the proton number. You have to say number of protons. You get nothing for saying number of electrons. It then asks you, use the information to explain why boron 10 and boron 11 are isotopes. Okay, so what you would have here is you'd have boron with a big number 10 and you'd have boron with a big number 11, but they tell you that the atomic number is 5 in both cases. So what that means is that boron is going to have the same number of protons because it's got an atomic number of 5, but it will have a different number of neutrons because the mass number is different. So if I just remind you, if you're working out protons, electrons and neutrons, for boron 10 it would be 5, 5, and 10 minus 5 is 5. And if I did it for boron 11, it would still be 5, 5. But now for neutrons, it's 11 minus 5 is 6. So they have the same number of protons, but they have a different number of neutrons, and that is your definition for an isotope. The particles and the mass of an electron is smaller than the mass of a proton. So the mass of an electron is smaller than the mass of a proton and neutron. Electrons are the lightest particle. This question I've given you before, and it's caught a few of you out because of this word here. Describe the number and type of particles in the nucleus of this atom. So they're talking to you about oxygen. They say the mass of this oxygen is 17, and they say the atomic number is 8. That means it has got 8 protons, and it has got 17 minus 8 is 9 neutrons in the nucleus. But it does not want you to talk about electrons because it's only asked for the nucleus, and if you mention electrons you're going to lose a mark. Okay, there's no electrons in the nucleus. If you did mention the word electrons, you would have to say there are 8 electrons in shells, but if you didn't say shells, they assume you think that the electrons are in the nucleus too, and they won't give you that mark. So sulfur and oxygen are both in group 6. Explain in terms of their electron configuration. That word electron configuration, it just means how their electrons are arranged. If they're in group 6, what do they have in common? They all have 6 electrons in their outer shell. You have to specify outer. Here it tells you phosphorus is 15. Describe how these electrons are arranged. So they're basically asking you for the electron configuration. So phosphorus will have 2 electrons in its first shell, 8 electrons in its second shell, and then 5 left over for the third shell. So that's all you need to write, 2, 8, 5 to get the 2 marks. And you can see from the electron configuration that phosphorus must be in group 5 because it's got 5 in its outer shell, and it would be in period 3 because it has 3 shells. A covalent bond, your definition is a shared pair of electrons. If you don't say the word pair, you're going to lose one of those marks. So a shared pair of electrons. The next one, the empirical formula. So this is the molecular formula. This is the number of atoms that you actually have. To get the empirical formula, all you need to do is divide across by the biggest number that goes evenly into 4 and 10. That number is 2. 4 divided by 2 is 2. 10 divided by 2 is 5. That's the simplest whole number ratio, so that is the empirical formula. This next question here is a gift, alright? It's one of the easiest calculation questions. You're asked to calculate the relative atomic mass of lithium. All you do is they'll give you a percentage and they'll give you a mass. So this is lithium 6, the mass of lithium is 6. It is not minus 6, that's just a dash. Okay, mass can never be negative. So you do percentage times mass. For the next one, you do percentage 92.41 times mass 7. Okay, and then you add these two together. That's where students sometimes go wrong. You need to put a big plus between those, and then because you're dealing with percentages, you're going to divide everything by 100. Now when you do that on your calculator, you're going to get an answer of 6.92. It says to 2 decimal places, so you get one to 6.92. And then you can check if your answer is reasonable by looking at your own periodic table. Okay, lithium on your periodic table has got a mass of 7. If your answer isn't close to 7, then you've definitely done something wrong. if your answer is close to 7, so mine 6.9 will round to 7, then I know I'm right. If you get an answer that's much, much bigger than what's on the periodic table, chances are you've multiplied between the brackets instead of adding. That's the main mistake. And if you've got another answer, again, that's maybe if you're coming out with 69.2, or sorry, 692, then you've obviously forgotten to divide by 100. So just look at the answer on the periodic table, you can check if you're right. The rest of these questions refer to what we're doing at the moment on the atmosphere. So it says the percentage of oxygen in today's atmosphere is greater than what it was in the early days. Why? So you need to say why we've got oxygen at the moment. So oxygen has been produced by plants through what process? Photosynthesis. So just plants photosynthesize will actually get you both marks there, mentioning plants and mentioning that they photosynthesize, and that produces oxygen. And the next question here, this is about your gas tests. So we've got 4 gases: hydrogen, oxygen, chlorine and carbon dioxide, that we need to know tests for, and this question here is testing you on that. So they're saying in one test you bubble the gas into lime water and you see a white precipitate after 4 minutes. With the other one, you're seeing a white precipitate after 10 seconds. Now, if you're using lime water, you are testing for carbon dioxide. This one here forms a white precipitate, which turns milky after 10 seconds. So I would say this here has lots of CO2 to turn milky after just 10 seconds. This must have some CO2 if it does eventually turn milky, but I would say it has very little CO2 if it's taking 4 minutes compared to 10 seconds. The other test they give you is a burning splint into a gas mixture. So a splint is just like a little wooden stick, and if it's burning, it's actually on fire, and if you put it into this particular gas, the splint continues to burn. If you put the splint into this gas, it goes out. Now, in order for burning to occur, there needs to be oxygen, and if the splint immediately goes out, that tells me that you've got no oxygen. That's why it goes out. It's extinguished because there's no oxygen. If it continues to burn here, you must have oxygen. Okay, so you've got gas P has only a little bit of CO2 and lots of O2, and what they're ultimately asking you is which one represents the early atmosphere. So you need to know early versus modern. In the early atmosphere we had lots of CO2 and we had no O2, and in the modern we only have a little bit of CO2 now and we do have O2. So which one of these gases represents the early atmosphere? Well, the early atmosphere, I want lots of CO2 and I want no O2, so my answer is Q. Okay, so Q represents the early atmosphere, and to explain why, you'll just need to say that the tests show that you've got lots of carbon dioxide, which is indicative of the early atmosphere, and you've got no oxygen, which is also indicative of the early atmosphere. The next question, gas Z. Figures of the Earth's early atmosphere. And I'm sure you, highlight the fact that it's early. So this one is really, really abundant, or there's a lot of it in the early atmosphere. What could it be? Early atmosphere, the answer is going to be B. You've got lots and lots of carbon dioxide from all of those volcanoes. The next one, the Earth's earliest rocks contain iron sulfide and no iron oxide. Later the rocks contain iron oxide as well as iron sulfide. Explain what happened to allow this change to occur. So way back in the day, there was essentially no oxygen, and if there's no oxygen, there's no iron oxide. Now we have oxygen. So for this change to have taken place, the oxygen must have increased. And now that we've got oxygen, the oxygen can react with iron. O2 can now react with iron to form iron oxide. Okay, before there was no oxygen to react with, now you've got oxygen and iron will react with it. Almost done. Question 22 is about the amount of gases in the Earth's early atmosphere. It says the amount of water vapor in today's is much less than the amount in the early. Explain why. So remember, back back in the early atmosphere, it was incredibly hot, and because it was so hot, instead of having liquid water on Earth, all of the water was present as water vapor. That's why it's so large. Now the Earth is much, much colder, and what happened is as the Earth cooled, the water condensed. And that's what's going to get you your 2 marks, telling me that the Earth cooled and then the water condensed because of it. That's why we don't have as much water vapor. Last one, we've got question 23. First one is just a multiple choice. Which row shows the approximate percentage of carbon dioxide thought to be in the Earth's early, and how this percentage changed from the Earth's atmosphere today? So in the early atmosphere, the percentage of CO2 is very high. So I'm going to be looking here, and now it's much, much lower. So it was high, now it's much, much lower. The answer must be D. And then it says here, the actual percentage of carbon dioxide in the atmosphere today varies. Explain 2 factors that cause the percentage in today's atmosphere to vary. There's a few different things that you can say here. One thing that we've looked at recently is the burning of fossil fuels. So we saw that when we burn fossil fuels, so combustion reactions, that we produce carbon dioxide and we can produce water. So I can say burning of fossil fuels, I'll say increases CO2. So all of those reactions we looked at, burning of fossil fuels, complete combustion, we're making CO2. Another thing, respiration is another, all right, us just breathing out. When we breathe out CO2, and CO2 is a product of respiration in our bodies, so that would also increase CO2. To explain a reason why CO2 levels can decrease, you can talk about plants photosynthesizing, so that takes in carbon dioxide. Plants photosynthesize, and that will decrease the levels of CO2. You can talk about carbon dioxide just dissolving in water. So in the early atmosphere there wasn't any oceans. Now that we have oceans, some carbon dioxide will dissolve in there. Deforestation, we are cutting down a lot of trees. Less trees means less photosynthesis, so that would lead to an increase. So there's quite a few things you can say, but for each one, make sure you state it and then state the effect it has on the carbon dioxide. Does it increase or does it decrease?